Welcome everybody to the Ecology Engagement Workshop. I see a lot of folks joining us today. It's very exciting. So we're here to talk about the impacts of light pollution on animals and wildlife more generally. And we have a panel of three speakers. I'm one of them who will be sort of leading this discussion. Um, ah, so who I would going to introduce right now, starting with Travis. You want to tell everybody a little bit about yourself?
Sure. My name is Travis Longcore. I'm an adjunct professor at the Institute of Environment and Sustainability at UCLA in Los Angeles, California, and do a lot of work on light pollution and wildlife.
Awesome, thank you. And Ipa, do you want to say a little bit about yourself?
Hi, my name is Ipa. So I'm a professional underwater photographer. I've been shooting videos and marine life of underwater, and I can see how light actually distracts animals inside the water. So I'm here today to do a storytelling on how it is and how it affects animal underwater.
Awesome. I'm really excited for that. So I see in the chat we've got people tuning in from all around the world. This is so amazing. And by the way, my name is Avalon, and I'm a research scientist at the Roland Institute at Harvard, where my lab studies the impact of light pollution on insects. I've done a lot of work on fireflies, that's the background, but these days I study moths and all sorts of insects that fly to lights. Um, and so we're going to start off by each of us sharing a few slides, sort of going into one aspect of how light affects animals and one story or stories that come from that. And I do believe Travis is going to go first. So if you're ready.
That's right. So I'll start with, I'll get this going. Just a summary slide, which is maybe we can refer back to and modify as we go along, but sort of four big areas where light at night, light pollution affects wildlife. And here, interesting, mostly in the terrestrial context, which is where I work most of the time. And so people will add to this. Attraction to lights, disorientation, fragmenting habitats by lights, interactions between species, in the form of pollination or predator-prey relationships. And then what I'll just give a little intro on for today is circadian rhythms and lunar and seasonal rhythms. So all the cycles where light over the long course of the history of the planet has been a very reliable giver of time, as it is in the German, the Zeitgeber, and it is disrupted by light at night. So those daily rhythms, seasonal lunar rhythms, day length rhythms, all those things are subject to influence. And so this picture usually convinces people that this is a real thing. This is a field of soybeans in Georgia, and the soybeans of this particular kind will set seed when it detects that the day length is getting short enough to know that winter is coming. And if it doesn't think that the days are short enough, it doesn't set seed and it stays green. So everything out here that's sort of, pale green and brown is setting seed, and there's soybeans to harvest there. As you get near this street light, however, and right under the street light, that's healthy green. It's growing. It's growing like it's summertime because the street light is actually bright enough for the soybeans to not think that the days are getting shorter or short enough so that they should set seed. And you see how this effect decreases going out from the light. And you can tell this is for real because there's actually a shadow of the light pole going right through the soybeans right there. There's the head of the light and the shadow from it on the field. So this would be an example of how light normally is giving seasonal cues in the form of day length, but in this instance, it's broken down entirely. And from an economic perspective, all of that is useless to the farmer because there's not going to be any soybeans to harvest there because the street light's taking care of it. So second thing, there's a lot of lunar sleep cycles in nature. And lunar cycles, in addition, I used sleep cycles because this is actually an example from people. We're part of the planet as well. And human sleep cycles are cued into lunar cycles. Now, do we know exactly if this is the light or not? I think it probably is. There's some other hypotheses that they're working on. But one thing for certain here is that this green line is freshmen in Seattle, Washington, because like many studies, it's done on the population at hand. And these two lines are from populations in South America of communities that either have no light or have limited access to light. And what you see is the greatest duration of sleep is this blue line. That's a community, an indigenous community in South America that has no electric light. The orange yellow line has some limited light, less sleep, and those college freshmen up at the University of Washington, same lunar cycle, maybe offset us slightly, but much less sleep. And so this is an indication of sort of daily and monthly cycles that are being influenced by, we presume, at least the height of these lines, the duration of sleep is absolutely associated with the amount of light available and the sort of for activity in the society. Now, those are circadian rhythms, the rhythms from day to day. And we think, that example was from people, but if we look at nocturnal mammals, for example, the threshold for affecting circadian rhythms, the timing of when activity starts and ends, can be very, very low. And this is actually a summary from 20 years ago. But if you look at this column right here, the threshold, 0.2 of a lux, that's moonlight, 10 to the -2 lux, 10 to the -4 lux. We're getting down into levels of light that are like starlight or a quarter moon or whatnot, that are sufficient to disrupt the circadian rhythms of these bat species, as an example. Now, of course, they're going to be roosting in very dark places, and in consequence that are usually going to be protected from the light. So they're super sensitive to it in order to be able to normally synchronize their rhythms with the daytime. So it does indicate that some very low levels of light can influence wildlife. And then if we think about all of the other sort of physiological things that go on with organisms that are associated with these rhythms on a daily and annual basis, birds are a great example. A ton of research here. Street lights can make birds lay eggs because that's day length, getting out of time with the season. Birds can forage later or earlier in the morning under artificial lights. Lots of studies on that. Date of lay changes, timing of migration changes, the molt can change, the time of singing song in the morning. All of these things are influences and changes from the light pollution environment on birds that now have been well documented for over a century. To be quite honest, if we look at the dates on the inducing street light laying of eggs on that first bullet point there. Now, then there's the question that I also want to cover of color, and just quickly go over how color influences the detection of light by species, either by the system that is governing the circadian rhythm or by visual systems that are just looking to identify objects in the environment by wildlife. So this is a picture of a bridge in Los Angeles with that very full, bright, high color temperature LEDs that everybody is so excited about, with the old high pressure sodium in the background. This is a picture comparing different light sources with different spectral compositions from Gerhard Eisenbeis and some of the early work on LEDs in Germany. And I have the time, just want to quickly go over this so that we're all familiar for conversations about how we talk about spectrum and color. So we use correlated color temperature to describe the composition, the spectral composition of light. It's not a perfect way to do it, but it's what we've got, and it's what most everybody understands language-wise. Low color temperatures have a lot of yellow and red. High color temperatures have a lot of blue. Daylight is, the standard is 6,500 Kelvin. A old incandescent is 2,700 Kelvin. I know I'm speaking to an educated group here, and you all know this already. The way that we go about trying to understand potential impacts is we cross-reference the spectral composition of light with the sensitivity of the sensor. And in the back here, this light color in the back is human daytime vision, our photopic vision. This is daylight over the different colors. And then the pastels in the front are how much it overlaps. So sort of how effective this light is at driving our daytime color vision. And so we can compare that to a high pressure sodium lamp, lots of oranges and reds and whatnot, still plenty of light that overlaps, but also an interesting amount of short wavelength light over here that's not so useful for our color vision. LEDs, a high color temperature LED, very heavy in the blue because of the technology. We can get into that if the discussion goes that direction. Plenty of overlap, though, with our daytime vision, full spectrum view of light. A lower color temperature LED just has a lot less of that blue. More of that blue light is re-radiated out here into the longer wavelengths. Plenty of overlap for human vision, and far less down here in areas where our color vision is not as sensitive. And to be quite honest, under most circumstances out there, we're not trying to use our non-color or our nighttime vision. We're actually using color vision. And so how do we relate that to other species? Just very quickly, this is a scatter plot of something like 170 different spectral responses in the eyes of different species of terrestrial wildlife. So for IPA, I haven't done the marine compendium yet. We'll get there, next project. And this is just the average. So like the average sensitivity of terrestrial wildlife is right here around 555 or so nanometers. And that's human peak. And the peak for everything else is a little bit shorter than that. And there are a bunch of species that have peaks over here in the near ultraviolet and into the ultraviolet as well. So light that humans are not seeing, even though I have them in purple down there, really, once you get down into this range, that's light that humans are filtering out in the cornea and not using for vision. If we summarize it, it looks a little bit like that. You can see the variability a little better in there. And then we can look at different groups. So amphibians, birds, whatnot, and sort of see the average, but also the variability within different groups of the ways in which they're seeing things. So reptiles all over the place, right? Birds have very broad spectral sensitivity. Insects, maybe it's a little bit more of a pattern, but we just have so many more measured that the mean is a little tighter. And so this helps us to sort of start understanding, if we want to treat things on the average, what it would look like. I cross-reference all of these with real lights that have real emission spectrum. So these are all the emissions at the different colors of light for a bunch of high pressure sodium, low pressure sodium, filtered lights. We have the full moon in there. We have burning oil, just a whole bunch of real lights. And then I cross-reference those things together and sort of predict how effective you would be at mitigating or minimizing the apparency of those lights if you were trying to give lights to humans, but reduce how bright they are to other species. And so there's just two probably quick things I want to say about this, and then I'll let y'all move on to the next, which is all those lines are positive, meaning that the higher the correlated color temperature, the more blue, the greater the impact, and that some of the lines are steeper than others, meaning color is more likely to be useful to reduce impacts for some groups than it is for other groups. And of course, there's a lot of variability within those that we can get into a bit later. So I will end it there with my current stuff. And I know that was probably like 9 minutes, but sorry.
No, it's all good. There's a lot of good stuff there. And I think there's so much to dig into in the discussion. So let's get there as soon as possible. I'll just say a few more things about light impacts on animals specifically. So hopefully this shows up okay. This is just the title slide. So to remind you all, I study insects. I'm hugely biased in favor of things that affect insects because I care about them a lot and they're very important for the functioning of our ecosystems more generally. But the things that happen to insects happen to a lot of other animals too. So I'm going to try to broaden the scope of what I talk about. Travis covered how light can interfere with daily and seasonal rhythms of activity. Um, that's one thing. There's another thing that light pollution does to animals that I think we can relate to really well. So probably almost all of us on the call today really enjoy looking at the stars, find it very beautiful and uh, spiritually edifying. And a lot of animals like to look at the stars too. So harbor seals and other animals, some birds, other species will actually use the stars to navigate. So when a harbor seal is out in the middle of the ocean, doesn't know which way to go, it needs to find a landmark to move with respect to. And they've actually learned to use stars as sort of stationary points that they can move with respect to, which is a pretty impressive thing. And animals surprise me every day, but of course they've had a long time to be out at night trying to figure things out. And so, they come up with a lot of fun approaches. The dung beetle also enjoys stargazing. So dung beetles are so named because they lay eggs in these balls of dung, and then their larvae develop inside the dung ball. And a dung beetle that finds a pile of dung needs to make a ball and roll it away from the source as fast as possible so nobody else takes it. And the way that they do this involves finding a way of moving in a straight line. So a dung beetle that finds a ball of dung will crawl on top and do a little circle looking up into the sky, find the Milky Way, and then sort of follow the line of the Milky Way or move with respect to the Milky Way. And so when they can see the Milky Way, they do this very beautiful straight dispersal, really like effective, efficient movement. When the Milky Way is obscured with sky glow, they get really disoriented and they move in circles. If they have the glow of a city on the horizon, they move towards that instead, which might not seem all that bad, but if as a whole group, a species decides to move towards a light instead of going anywhere else, it leads to a lot of weird and bad things. So I think Ipa is going to talk a little bit about baby sea turtles, so I won't go into it too much here, but they also move towards lights when trying to find the ocean. If that light isn't the reflection of moonlight, but instead a car light, a house light, it's not so great. A lot of birds move towards lights. Seabirds striking lighthouses is a phenomenon that's been observed for hundreds of years. And more recently, these lights set up at the site of the Twin Towers as a memorial to the victims of 9/11. These lights shine up into the sky each year on September 11th, and they attract birds. And from miles and miles and miles, these birds get trapped inside these columns of light and sort of circle endlessly, which is not a great thing to do as a bird. There's other more important activities you should be getting up to. Insects do this too. So moths are a sort of classic example, but all sorts of insects fly to lights and circle them endlessly instead of, again, doing the things they're supposed to be doing, which is foraging, finding mates, laying eggs, that kind of stuff. Sometimes a whole bunch of insects, and this is a mayfly emergence, they all come and lay eggs on this bridge underneath the streetlights because to them, it looks like the lights are shining off of water. It's again this sort of visual confusion. Their eggs are supposed to be in water and not on a cement bridge, so this is a pretty damaging behavior. And also a lot of insects that fly to lights get eaten by bats, so bats will come to lights to feed some of the time, and then it brings the bats into contact with humans where they might otherwise not be. Other types of bats avoid lights entirely, and so their amount of habitat, available habitat, gets much smaller because of this. So in this way, light shapes movement, and that shapes who is where at what time, which has all these sort of cascading impacts. And so the final thing I'll mention is that for every thing I've talked about thus far involving an animal going to a light, there's an opposite story, which is an animal hiding from a light. And so often as ecologists, we don't see this because it's really hard to see something that isn't there. But we know that the animals that go to light are really affected in this way. The other half that don't go, you could make some guesses that there's pretty big impact there as well. A final fun fact is some crickets don't like being the subject of photography and will actually lift their front leg to shield their eyes from a camera flash, literally blocking out the light, perhaps because it's painful in some way. So they don't want your camera flashes either. And so hopefully for the discussion today, we can come up with a few ways of letting the katydids and grasshoppers be at peace. Awesome. So make a great time. Ipa, do you want to?
Okay, I'll go on with mine. Just give me a minute. Let me share my screen first. So today I'll be talking about how natural light is going to disrupt the marine life inside here. Hold on, let me check whether my video is okay. Okay. All right, sorry guys. All right, so how light affects the underwater world. So while everybody is talking about how the sun and the lights and everything and the unnatural lights in the world is actually affecting the bugs and the plants and everything. Now, this is how unnatural lights is actually affecting the underwater world. Now, I'm just going to talk a simple basic one regarding the pygmy seahorse, the turtles, the big marine mammals that you just saw a short while ago, and other marine lives. So basically inside the water, I'm always shooting the animals, right? Oops, naputus eh. Can you see me?
No, your video is off.
My video's off, but you can hear me?
Yeah,
Can you still
sound
see
great.
everything?
Yeah, sounds great.
Okay. Can you see the video still? Okay. So basically, for me inside the water, I've been doing diving for close to 20 years, and I've been observing and capturing animals in videos and photographies. And I'm starting to see how the lights are affecting the animals inside the water. Now, let me give you an example of the pygmy seahorse over here. It's a beautiful seahorse, you know, staying at the sea pen and everything like that. It's nicely captured. But from here, I actually took it with natural light with very, very minimal light. Now, this was taken recently in an island called Slacken Island. But 10 years ago, I actually had the experience of seeing a pygmy seahorse died right in front of my eyes because a photographer started shooting with strobes that is so strong in lumens, more than maybe 15,000 K Kelvin and stuff like that. And it started to like, you know, lights being light, if it gets close to the animal, it's like roasting them to pieces. And I saw this Argivanti seahorse died right in front of my eyes. That's when I realized, like, oh no, this is not good. All this unnatural light that we're all producing inside here is actually disrupting all this marine life. And when it comes to pygmy seahorses, during the day they're always active, but at night they're always sleeping. So when we have divers that goes at night and actually start shooting the Bargibanti, you are disrupting their sleep. That's when they get so stressed that the next day you'll see the sea fan starts dying. You can see the stress inside the animal. It's not like participating with you. Basically, it's like hiding towards or running away from you. So it's not a nice thing. Then we have this, like disrupting natural behaviors of the underwater world. While marine photography can be educational, inspirational, the troubling reality is the process of taking those photos can sometimes cause, usually temporarily or minor harm to marine animals. So this is what I've noticed. Now, recently, in the island that I went in, we actually managed to capture a very beautiful cryptic frogfish, we call it. Now, this is very rare. They only come by up here every 6 years to give birth, and they go back down again to deep water only after a few months. So we get to see them every 6 years. So we had one of the divers, you know, to manage finding this frogfish. But look how the frogfish, let me see. You see how stressed the frogfish is. Now, because the lights were very, very strong, you can see it's huddling at the side there and trying to run away. And you can she is actually pregnant. You see the pouch down there? So she was actually trying to protect herself. The light was decided because that is how their nature is. So it was pretty upsetting, but it was a good video to show. Then we have, like everyone says, the sea turtles. Oh, the sea turtles. When I see this image and I see a sea turtle being released during the daytime, a lot of people don't know that sea turtles only hatches at night. Am I right, Evelyn? It only hatches at night because it's trying to run away. During the daytime, the other predators that are seeing them can see them from far. Hence, that's why our turtle population is getting less and less. So what we do now is basically when we release turtles at night, we make sure all the lights are off. So they can use a navigational system like Evelyn says, the stars, the moon, so they can navigate themselves away from there. Now, these sea turtles, especially the young hatchlings, they have this amount of energy. So if you have an unnatural light obstructing their movement, they don't know where to go. At one point, the sea turtles will become so weak for the for the predators to actually come and catch them. But I have heard a few countries in the world right now where they are banning lights across the beaches during turtle season when they're about to hatch. This is a good thing to do, and I hope everybody around the world will actually follow this system where during during the time they lay their eggs, or during the time that they hatch, they would actually switch off the lights. Because like female turtles, when they're about to hatch, they will always look for a dark place. They'll dig in and put the eggs inside there and they cover up. Nowadays, we are seeing a lot of turtles basically everywhere because of the disruption of light. I've seen some under the cars or between the trees, but they don't know how to go back, to the ocean because of the unnatural lights. Now, the sea turtles, the female, when they're about to give birth, they will always, like I said, look for a dark place. When they see it's too bright, chances are they're not going to give birth there. They're going to go give birth somewhere else. But the thing is, every turtle is built in with a GPS system inside them. Where they are born is where they lay their eggs. So when we disrupt that, it's a big thing. And sea turtle plays a big part in our ecosystem, actually. Then we have this. Okay. I was in Maldives recently, and I was actually watching the whale shark, the feeding and everything. So we were on a big boat. And as you can see over there, I'm going to play this. Do you see the unnatural light on top there? That's the light from the boat. Now, I was here during what you call that, a place called Haniparu Bay, where all the whale sharks gather in a migration pattern. So all these boats over here, what they do is they trick the plankton into coming by having this big light in front of them, and you can see the ecosystem going around. Let me play that again. You see the planktons coming in, then the small fish coming in, then the slightly bigger fish, the dolphins were actually down there hunting the smaller fish, and the whale sharks are there and feeding the planktons. Now, the thing with this, I don't really condone in this kind of thing, but because it's inside the bay where it's protected and it's always that season, so I kind of close my eyes on that one. But it does show a system where if this is practiced elsewhere that is not a migrational pattern, it's going to disrupt where it's going, because whale sharks also follow where the planktons are. They can smell them from a mile away. So let's just say a building is so bright in another beaches over there, and they start actually, putting lights and putting the planktons, the whale sharks are going there. So it's going to disrupt their migration pattern. And same way as the, what you call it? Oh, why am I not going forward? Hold on, sorry. As the mantas as well, as you can see, they're feeding on the planktons. You can see the divers over there shooting, but I make sure that they switch off the water in order for not to blind the mantas, because once they are there, they're confused. They don't know what to do. So they circle and they feed and they go again. And once the lights are off and the planktons are gone, they move off to the other way. Then we have the other species like the fish, where sometimes we see a lot of photographers using really strong lights or really strong strobes. It blinds the animal temporarily. And when these animals are blinded inside the water, especially the fishes, it gets really, the predator fish will actually come over to them and you can see them being attacked. And I've seen this in front of my eyes several times where the fish are blinded. Like example, the goby and the shrimp, they work together. It's a symbiotic, what do you call that? oh, what's that word? Life. They live together. So the shrimp is blind. The goby is actually really, really, they come in pairs usually. So they are basically the guardians. The shrimp cleans the house. Basically, they are the maid of the water. So they clean up. But when a predator comes by, the fish's tail is like, push the shrimp back in. Now, the thing is, if let's just say they are temporarily blinded and they can't have enough time to tell the shrimp that, it has to go back inside the house with his so-called strobes of very strong light, that's when the other big fishes that goes around, you can see them circling, waiting to just attack them, which is pretty sad actually. And these are a few examples of the fishes that I took inside there that are very, very, how to say, sensitive to lights, especially like the panda Nemo, the goby fish, and all this over here. They love lights, but during nighttime they are asleep. So when we get divers going there and waking them up, we are changing their sleep cycle, which is also not good, will stress the fish. Then you'll see it become less and less. And it does affect them because the mating ritual will be different. The feeding ritual will be different. So basically it affects a lot. So, and that's it. Now, inside the water, I'm starting to see a lot of photographers using blue lights. I don't know why, maybe for some creative reason, but the blue light does disrupt the animal inside the water. And I see it stresses them more. I'm not sure. I'm going to ask Travis about this more because I just saw that he gave the graph, and I'm going to ask you a lot of questions, Travis, on this for sure. And then the last video I'm going to show you how, when I actually shot inside the water with my video lights, and you see how the animal goes by. Let's see their behaviors. So you see the reef fishes here. I'm going up towards them, slowly, and you can see the fishes get brighter because the light is hitting the fish nicely. But look at the fish. It's getting closer and closer and closer to the reef. They're huddling all together because they do not like the natural light. Because when they have that, what they do is they protect themselves across each other, the bigger ones outside, the smaller ones inside. So they would be protected from all the predators out there. And I think that's it.
Whoa.
And we are done. Yeah.
Wow, thank you for that. That's stunning, just stunning and so interesting.
Something different inside the water. Yeah.
Yeah. Great. Well, we've made great time, so let's have a little bit of a Q&A. I encourage everybody to put their questions in the Q&A portion of the Zoom window, not the chat, although I have been enjoying reading your chats as well. So right now we've got a ton for Travis. The people are dying to know more about your graphs, the colors, and I'll start with I'm going to start with the second question, just to throw you off. So, would it make sense to look at the absolute sensitivity of different animals in addition to their relative sensitivity to gain insight into how bright the environment looks to them?
The short answer to that is great question. Yes, of course it would make sense. I haven't done it. So that's not every study that does measures the spectral sensitivity also measures the level at which each of those is being triggered, or does it in a way that is easy to synthesize. I think it's on the sort of medium range to-do list to try to start compiling some of those, because I'm interested in the same question.
All right, very good. Do you think it's how much do you think it varies?
I think it varies orders of magnitude, to be quite honest, especially for nocturnal species that are adapted. They're just seeing a world that we as humans aren't seeing because they're that much more sensitive. So yeah, it's going to be a pretty big range.
Right. Well, future project, perhaps.
Mm-hmm.
And then I think this is a good one. I should have asked this one first, which is like, could you explain to everybody like how you're getting these curves? Like, how do we
Sure.
know what an animal
Yeah.
sees?
Okay. So first of all, I need to be very clear that I'm not a real biologist. I'm a geographer, and so I'm synthesizing stuff that other people have done. And there's three ways that we get these curves of sensitivity to different wavelengths. One of them is actual behavioral, where they train an animal to react to a color for a reward. So like a chicken, like peck on this side if you see the color, and the other, and then you get a treat. So that's number one, is behavioral, and they tend to be actually trained that way. The second is what are called electroretinograms, where they attach a diode to the eye, and they measure the amount of electrical stimulus from the different colors. And so this is what most of those curves are from, known as ERGs, electroretinograms. And so it can be done with living organisms. It can also be done with sort of recently deceased insect eyes. So that's a little tougher to take, but that's how they do it. And the third way is reflectance, where you shine a light and measure how much reflects, and then the inverse of the reflectance is the amount that's being absorbed, and therefore is the amount that's being changed into a signal to the organism. So reflectance, ERGs, and behavioral.
All right. Okay, thank you. I want to ask more questions about that, but I'm going to keep popping around in the Q&A. And I'm going to ask one of myself, the most recent one, because it has to do with exactly what you're saying. So does artificial light at night affect insects in the UV spectrum as well, since bees and such can see UV? So Travis's curves, they went into that UV short wavelength range. And if you remember what the insect one looks like, we've got like a bunch of sensitivity in the UV. Actually, a lot of insects see UV. It's kind of, if humans are like tend to be red, green, blue, insects tend to be UV blue, green. And so that UV cone is like pretty old. So certainly lights that put out UV wavelengths affect insects a lot. And in fact, for whatever reason, UV light is especially attractive to insects that fly to lights. And so people who want to look at insects use UV lights to attract moths and other insects in order to study them. Why UV in particular? It just turns out that like insects are really good at seeing it overall. Why are they so good at seeing it? I think this is a really deep question, actually, but it might have something to do with that circadian regulation that Travis was talking about, because the UV in the sky varies quite a lot at dawn and dusk, and it's kind of an interesting cue in that way. And also, UV light makes it really easy to tell the top of a leaf from the bottom of a leaf, which might not seem that important to you and me, but to an insect, that's like everything. And so they might be using it for that as well. So certainly UV is extra impactful to insects. We don't recommend that people have UV in their lights anyways, because humans can't see them, so it's not doing us any good. So that would be like number one thing to avoid for sure. So Ipa, I wanted to ask you, well, actually, I'll let Katie ask you, what would be the best way to educate people on how the animals are impacted by lights?
Okay, one of them, basically, this is a very deep question as well. Now, I get a lot of students asking me, now, what's the best way to actually shoot without them, being hurt and stuff like that? So when I teach underwater photography and I teach behavior inside the water, because I study the animals a lot, I always tell them like this, okay? That lights, especially underwater lights, they're not like normal torches that we have on land. Basically, they are much more stronger inside the water because light bends differently inside the water and it reaches less. Like over here on land, you can see it as far as possible. But inside the water, a lot of people don't know that light, maximum depth, how to say, the length that they can go is only up to 2 meters. So imagine you have strong lumen lights, right? And you're starting to shoot the animal with a very strong lumen light, especially when you want to play macro photography. It's really blinding. It's really blinding. And then you can start to see that the animal is starting to squirm inside the water because of the heat from the light. So when they start squirming, they start getting stressed, they start hiding. And then it stresses the photographer because they can't get. So it's basically not a win-win situation for everyone. In all this kind of animal, you have to start taking them with, like how Travis says, a certain Kelvin of lights inside there. So basically our sun Kelvin is about 6,000 K. Is that right, Travis?
The
What's our light? About 6,000 K?
well,
The sun.
oh,
Yeah.
the sun. So there's a difference between the correlated color temperature, the Kelvin, and the brightness, right? So the
Yeah,
color,
yeah.
daylight
Exactly.
is
So the
6,500, but that's the composition of it, blue to yellow. Yeah.
exactly. Blue to yellow. So basically inside the water, when I start teaching them, I start teaching them to use a torch that's
Mhm.
maybe around that range. So it doesn't really disrupt them, and you can actually shoot them properly as well. But I also tell them at the same time, you cannot have prolonged lights on them. They'll be like roasted chicken basically inside there. It's like you having a torch and putting it in your hand, and you can feel the heat on your hand. So
Mhm.
imagine when something is this small and the light is really strong, definitely something is going to happen to the animal. It's going to get stressed and stuff like that. And it stresses the driver. It's just not a good thing. So we
Mhm.
tell them, try to use less. If you start seeing the animal starting to get, really stressed, pull away. Give it time. If it takes 10, 20 minutes to reshoot again, by all means go. But don't stress the animal out, because it's a sad thing to see inside the water.
Yeah, for
Yeah.
sure. Um, yeah, no,
Yeah.
thank you for that perspective. I think it's also interesting the challenges. So working with photographers, like
Oh,
I actually, having had a couple of people interested in filming fireflies, like follow me out into the field and try to film the fireflies using their cameras. And I won't get into it here, but it's been a little bit aggravating at times because you have to realize there's this balance between what the photographer wants and what the animal wants. And in theory, we're all here for the animals, right? So we should try to do
I
the
know.
thing as much as possible.
And we try to educate them as much as possible, that's for sure.
Yeah, no, absolutely. And so, Travis, I was wondering if you could sort of talk a little bit about, so Samyukta's question is about, overall recommendations. Do we just say lower CCT and go from there? What about all these exceptions? And then I wonder if you could also put in that a little bit about how do you convince people to change to a lower CCT light? What do you
Yeah.
do?
Yeah.
Yeah.
Okay. So I agree that there's no silver bullet. That's definitely true, and we kind of have sensed that for a couple of decades now, that there's always something that you're going to be influencing. I generally now, and based on some research I didn't talk about yet, try to start everybody with using the right amount of light and getting it on the subject first. That is, the color is not a get out of jail free card. And there are people and industry, perhaps representatives, who would love to just say, oh, this is a wildlife friendly light because it's a lower color temperature. And that's not the case. And so I always am trying to get people to recognize that any situation, you should be looking at, do you need the light? One, how bright does it actually need to be? And not brighter. Can it be shielded so that it goes where it needs to go and not visible from other locations? 3. Or how long does it need to be on, or can it be dimmed at a certain point? So a parking lot, does it have to be illuminated at 3 a.m? And can we go down to 1/10 power instead of full power and whatnot? And then in addition, on average, lower color temperature is going to be better. Now, better is a subjective term, and the exceptions there are like bioluminescent organisms that may be sensitive specifically to those longer wavelengths, in which case the answer is you can't be lighting them up, period. But if we have to have lights, and in many situations where I'm dealing is where there's legal pressure, or pressure by lawyers, shall we say, that you have to have things illuminated at a certain level, we can get away with changing the color temperature, reducing the blue light,
Yeah.
increasing yellow and red. And for some species groups, that's going to, on average, reduce impacts. It will reduce insect attraction. We've now shown that in a few studies, just sort of predicting the effects and going forward. It will reduce seabird attraction. There's a preprint out just this week from New Zealand that shows this. They calculated ahead of time using our sensitivity curves what the attractiveness of different lights would be at different brightnesses, and synthesized it, and it came out exactly like it would have been predicted using this approach. Ordinally, nominally, not like you know, a straight, you know, perfect correlation, but it ranked them up. It's like, this will be most attractive, that will be least attractive, and that's exactly what happened. So I do include CCT recommendations. The way to get people to do it, there are sort of two hurdles to overcome. You know, one is that they tend to be slightly less energy efficient than higher color temperature LEDs. And that one, you've just got to play the, isn't it, you're already saving, you know, whatever it is, 50% or 80%. Can't we just take a 5% hit on this number that's already tiny in order to do it right? Right. And appeal to their, you know, their better angels, as it were. Another is getting it. So there's that piece. Then there's availability. Can you actually get the lights at the lower color temperature for the application? And I'll take the opportunity to answer a question that's in there as we do this, which is, what about the Wallace-Annenberg crossing in Southern California? The answer to that is, I'm consulting the Wallace-Annenberg crossing, monitoring light, and in the design. And one of the issues there in recommendations is to make sure that underneath the tunnel is lit with the lowest color temperature we can get at the lowest levels we're allowed to light it. And making sure that there are products available in the market that can fulfill that need. And so there's a lot of, on the one hand, please spend a tiny little bit more on energy for this to do it right. But also here, and I do this not just for that project, but other projects, here are 5 manufacturers that are willing to deliver to you 1800 Kelvin LEDs that are rated for street lighting, or vibrations under bridges or whatnot. So being able to provide the solution off the shelf, and that comes from, you know, talking to people over the years and saying, hey, yeah, lower CCT lamps are coming. We really want them in environmentally sensitive areas. Yes, it's worth it for your company to go ahead and provide that as a matter of course, as opposed to, you know, some special order.
I thank you for that. That's just a really interesting perspective. And I want to I'm going to attempt to summarize what my sort of sense is of the past 10, 15 year 20 years of this sort of subject developing, because I think you know, in the mid 2010s, we were sort of undergoing this sudden transition from these warmer, high pressure sodium, even low pressure sodium lights to the super blue rich LED, super bright, super blue. It was like that. And then all of a sudden, all of these like animal effects, all this weirdness crops up. Like the birds are hitting the buildings, like we don't know what's happening. And so there was a while there where a lot of these replacements hadn't happened. And it was sort of the ecologist's job, along with other folks at Dark Sky International and elsewhere, to be like, well, you know, before you switch to your blue rich LED, maybe consider a longer wavelength, warmer LED. But what you're talking about now is we're sort of in LED world, and we're like in the blue rich LED world. So how do we move from a cool white LED to a warm white LED? And that like minor difference in energy efficiency actually becomes important. And it sort of, you like to think that environmentally friendly lighting always saves money, but this is the way in which it does it, and that's a little bit tricky. So I'm just restating what you said, but I just think it's really interesting. Okay. So Ken and Shelby,
Very.
we're going to talk about the moon, the moths and the moon. Yes. So if you put out a light and you want to catch moths, which a lot of people do, and you put that light out every night, you'll notice that during the full moon, you catch a lot fewer moths. It's a pretty stark difference. During the full moon, you also see fewer fireflies in open areas. It's kind of a similar thing. And so that's been known for a very long time. So for a while, people thought maybe it's because there's just fewer moths around during the full moon. But some studies since then have suggested that probably what's happening at some level. Oh, oh,
Oh no,
oh no.
we lost Eva.
We lost Aoife. I hope she's okay. At some level, the moth is using the moon as a navigational cue, and when the moon is less visible, they'll find a streetlight instead and use that, and then that might make them end up closer to the streetlight over time as they trying to move in a straight line. Ah, here we go. So the fact that the moon's used for navigation means that when the moon is full, they can use it really well. And so they always get where they're going. And so you don't see them at your lights, essentially. That's like another way of putting it. So when we measure insect activity under varying moon phases, it looks like there's a lot less, but our methods of measurement are kind of skewed in this way. Okay. And then the question about what the moon does versus what Alan does. So like a streetlight can be as bright, can seem as bright on the ground as the moon is, because the moon's very far away. But I don't know exactly how to answer this. I think it's fairly rare for a streetlight to totally replace the moon and become a more powerful cue than the moon, because the position of the moon in the sky, and it's it just makes it a little bit more. I'm not backing this up with scientific evidence, so only vibes. I think the moon is fairly if it's there and full, the insects know that it's the real thing, and I don't think they're as confused. But it's under these sort of when it's less full, when there's clouds, all this stuff, then things become more confusing, and lights on the ground can have all these effects, I guess.
And so there's also, I think you maybe were mentioning this, but I just want to come back to it, that contrast plays a big role in sort of attraction and confusion. And so there's both studies looking at attraction in birds and in insects, that when there's a full moon, there's kind of less confusion. And when they're not, and when there's light polluted situation, that any individual light is going to be sort of less attractive because the contrast between it and its background is less. So I think there's two things. There's is the moon being detected as an object, and how is the moon affecting the sort of illumination of the scene? And so the tropical insect collectors I used to talk to would be the place that has the most insects ever is that last phone booth at the end of nowhere that's got no lights around it. And that same phone booth in a light polluted environment wouldn't be having anywhere near the number of insects attracted to it. So there's sort of this washing out and reducing of contrast that happens both with sky glow and urban light pollution and with the full moon, and that it comes out in both insect and bird attraction studies. Yeah. Verheyen looked at this, speaking of the early people in the discipline.
Yes. Okay. No, that's
can I add on something about the moon that you were talking about? No, that's actually a very interesting fact, because when you talk about moon and how everything changes with the animals, how the animal follows the rhythm of the moon, it's the same thing as coral spawning as well when we have that kind of season. Yes. Because the coral spawning depends on the moon, because the moon basically is pulling the tides
Yep.
either to the highest or to the lowest, right? So this coral spawning thing, I read one article before, I cannot remember where, it was backed up by a scientist. It was saying that the unnatural light that is closer to the reefs, which is usually at the beach side, is starting to, how to say, the coral spawning is becoming lesser and lesser because the corals are confused when to let go of the sperms and
Yes.
the eggs.
Yeah.
So this is a very big thing, and I've seen it happens when we're supposed to go to a season where it's actually coral spawning. The time is right, the tiding is right, all this is right, but it just did not want to spawn. So when
Yeah.
they kind of like figured out, oh, maybe because the resort is lighted all the time, so animals inside the water, they get confused and just don't know what to do. Same as corals as well. While some people think corals are not live being, they're all alive.
Yeah. So there's a study,
Yeah.
a guy named Jokiel in 1979 looked at the desynchronization of coral spawning under artificial light. And so,
Correct.
but at the time, and that was in an aquarium study. But then there was recently confirmation of that in the field. And it's one of the reasons
Yeah.
we did that paper 10, 15 years ago about global exposure of coral reefs to light at night. And part of it was the spawning, and we have a whole section in there about sort of the mechanisms why we care. Why should it matter
Correct.
how close coral reefs are to urban lights? Yeah.
If they knew how coral reefs are so important, they're like 70% of our oxygen of the world. It's all coming from there. If we can't protect that, then we're actually in really big trouble.
Yeah, you're telling me.
Yeah.
So I want to do another. I'm going to try another little summary thing just based on what I'm hearing and thinking about as we're talking. Because it strikes me that Ipa, you're in these very, very natural spaces. I'm imagining. I mean, maybe you could describe in a second.
Open zoo. An open zoo.
Like it's just like there's no human infrastructure, right? People are coming in boats, but right? Very dark. And Travis is talking about, the underpass. We're like in LA, we're making street lighting decisions in the city. And I don't know, somewhere in the middle. I think about fireflies and moths in like backyards and suburban parks and nature reserves in New England. And at each of these scales, contrast becomes really important. And thank you, Travis, for saying contrast. That's exactly what I needed before, which is, the effect of a light it does not depend on the light itself, but it's the light in the context. And so Travis's streetlights, they're part of that big light environment, that urban light environment. And by making this public lighting as well informed by science as possible, we can change the entire urban light environment to be a little bit better. In a firefly reserve or any sort of park where there are fireflies, we don't need to really do anything except for make sure that people are safe when they're there, and then make sure that the fireflies have darkness. And so that's when we get into these like little you can so for fireflies you can use a special color of light, right? So we talk about red, blue is another option, but more than anything it's like using headlamps and flashlights instead of streetlights, that kind of thing. And then for photography as well, I mean, and I think we had a question about I'll really get to everything in the Q&A about advances in camera sensitivity, making it possible to record using ambient light. And like you have those concerns. So maybe as I finish the summary, you could talk a little bit about about Todd's questions about camera sensitivity, and also just like maybe describe for me, like if you are at one of your spots and you turn out all the lights, like, can you see any other human lights around or not? Or what's that like? Hard question.
That's for me?
Yeah, it's for
Is
you.
that for me or is that for Travis?
It's for you.
Okay. Let's talk about night diving, basically. So a lot of divers, they love night diving. And we know that, nighttime, basically we all sleep. Same thing as animal inside the water. So sad to say, that when you do use the lights inside the water, there was one incident where, as you all know, parrotfishes, they contribute to a lot of our sands in this whole entire world, and we actually need them. They're very, very important part of an ecosystem. So we had a few divers inside the water where diving, and they found this very nice, beautiful parrotfish, beautiful color, tropical, you know. And they went there and they started seeing sharks going about. Now, sharks always hunts at night because that's their nature. They do that. Now, out comes one time, there was a diver there shooting a very nice parrotfish. Now, with parrotfish, in order for them to protect themselves from predators outside there, they have their own saliva where they actually put it right in front of the coral. So the other animals inside there, they cannot smell them inside there. Now, I had this one very new diver at that time because he wanted to take a nice clean picture, basically, which everybody does. But because he saw that saliva of from the parrotfish, he kind of like just moved it away, move the force field away from the fish, basically. And at that moment, within a few seconds, the sharks came by and just can kind of eat them really, really fast. And this happened right in front of my eyes. And I'm like, well, that's not a good thing. Then I realized that sharks, even though they are semi-blind, they are also attracted to lights. So they come and follow you, same as barracudas and a lot of like big, huge fish. They are attracted to light, like how the deep waters are, the bigger they are, the more they're attracted to light, because to them, it looks like a shimmering food passing by. So as divers, when we have torch inside the water, it looks as if we are fishes inside there, and we are shooting and stuff like that, and shooting a nudie or a fish or something. Those animals, if you realize it, they're actually all around us. They're just waiting for an opportunity to see what it is, because for them, they see now, then they see light, and they think, oh, it's daytime, it's time for me to go on a hunt as well. So they go and they just eat it up and it's gone. So I always tell my divers inside the water, when you are about to shoot, minimum light, like how Travis says, minimum light is always the best. If you need to change your camera up to a certain Kelvin in order to suit your perspective of whatever photography that you want. So it's a very controversial thing, but at least I'm here to tell you about what happened inside the waters, and how to reduce that light pollution in order for them to be safe and for us to be safe as well.
Yeah.
Yeah.
I want to just get coffee and learn everything about your life. This is so cool. But I do also want to
Oh my God. Yes, you can.
Okay, great. And like all 101 in the chat. I hope we could all go. I want to be cognizant of time and sort of wrap it up here. We have a lot of leftover Qs waiting for their As. If you have any burning questions that you really want to talk more about, I'm sure my contact information are somewhere in this event. And I also am going to tell you, sorry, I'm scrolling rapidly. You should all know that the next session of Under One Sky is Regional Stories and Experts, Europe, Middle East, Africa, and India. Starts at 5 a.m. Eastern Time, 10 a.m. UTC, and it should be pretty exciting. So be on the lookout for that. I guess I'll put the link in the chat. And otherwise, do either of you have some final thoughts that you'd like to share?
Travis, you go ahead.
Well, hey, this is fun. And that's the thing about this topic, is it's infinitely interesting. And when you communicate to people about it, almost every time they can learn something, and you can just sort of poke around to figure out what it is that motivates them and interests them. It's like, oh, well, how's your sleep, and get them into circadian rhythms and blue light and melatonin suppression or whatnot. Or, oh, I hear you care about birds. Well, did you know that there's poor wills that live around here and are very sensitive to light and the insects, and so maybe we can change this light from a high color temperature to a low color temperature and put it on a motion detector instead of having it on all night. You know, there's just, I think it's just so fascinating, and what, you know, we've learned so much really about these things. Plenty more to learn. Enough for a full career ahead of Avalon, right? But we have so much we can draw on that just is interesting to people, and can relate to them if they care about the world at all. And I hope for those people to be out there, and that there's a spark. There's always a spark when you're talking about the night, and stars and wildlife and just the feelings that we all get in that environment. So I encourage everybody to use that. It's the great advantage of the wildlife side, is just the infinite interesting stories to draw people in.
Yeah.
Beautifully
You know what? I actually learned a lot from this one. I'm starting to see that the ecosystem does not, it affects underwater, but actually the whole entire ecosystem of the world is affecting from land to underwater to the skies, everything. And it's a good thing for me to actually practice that, because when I'm underwater now, I do know how to teach, you know, other people outside a little bit more about and how to care what we have right now for future generations.
Yeah.
Yeah.
Wonderful. And what do I want to say? I think, I mean, you're both so right about stories. And I think getting people interested in nature as a way of getting them to change their behavior is really powerful.
Yeah.
I've studied fireflies for a long time and done firefly-related dark sky advocacy, and found it really energizing. People love fireflies. They want to do things that make their yard firefly friendly and that can protect firefly populations, and that's really beautiful. And the sea turtles are really motivating, and owls, the songbirds, like it's all very compelling. And I think it's really cool that we're in this stage of the field where we're investigating these different systems and studying the effects and trying to look at different mitigation measures and sort of tailoring things and getting at the nuance. But I think it's also good to remember to take a step back, and similar to what Ruskin was saying in the chat earlier about the cost savings of ecologically friendly lighting. The best light of all is no light, and it's also really cheap. You don't have to worry about the color or shielding or brightness or anything. It's just no light, and that is always going to be the best because that's the natural state of the world, right? That's what animals evolved to live within.
Yeah.
And so that is easy. All the rest sort of, you know, those are the details, but you know, people love animals. We want to protect animals. Animals need dark nights. Turn out the lights. Boom. And I just think that's maybe something to, oh, and then also yes, Ruskin in the chat. Do some more, yeah, more PhD research.
Yeah, I saw
Yeah,
that as well.
yeah.
Do it at night.
Yeah, I dropped my
That's a good
email
one.
in the chat, and maybe everybody should, if you want to get questions or anything afterwards. I may refer you to another talk that's recorded and on my website or something, or send you a paper, but I'm happy to answer questions.
All right, yeah, I'll put mine too.
Yeah.
Great.
Okay, I've put mine on Instagram because I'm basically always on Instagram, so you can actually find me there. And if you have questions about underwaters and how to actually really protect the marine life, I'm there.
Great. All right, thank you, everybody. I think we'll, I don't know how to unpin myself. Just, I think we'll leave it there.
We're done. Someone just has to shut us off. Thanks, everybody.
Okay. Thank you, everyone. We'll
Thanks,
see you again
all.
next year. Bye.